Number patterns revisited. Example 2. A mosaic arrangement is constructed on a floor as shown. Find the number of tiles needed for the 30th pattern. So the first pattern has 1 tile. The second pattern has 2 plus 1, which makes 3. The next pattern has 3 plus 2 plus 1, which is 6. And the next pattern has 4 plus 3 plus 2 plus 1, which is 10. So writing it out as a sequence, we have 1, 3, 6, 10, ... So to get from 1 to 3, we add 2. To get from 3 to 6, we add 3. To get from 6 to 10, we add 4. So 2, 3, and 4 is the first difference. Since the first difference is not the same, we know that this is not a linear sequence, because in order for it to be a linear sequence, the first difference has to be the same. So we then go and have a look and see what the second difference is. So to get from 2 to 3, we add 1. To get from 3 to 4, we add 1. So the second difference is the same. It's 1. So therefore, the pattern is quadratic. So the formula for a quadratic sequence is Tn equals an squared plus bn plus c. So 2a is equal to term 1. So 2a is equal to 1 because term 1 has 1 tile. And solving for a, dividing both sides by 2, we get a equal to a half. So we're going to have a half n squared at the start of our formula. So Tn is equal to a half n squared plus bn plus c. So we have 1, 3, 6, and 10. And Tn is equal to a half n squared plus bn plus c. So this is from the previous slide. So T1 is equal to a half times 1 squared plus b times 1 plus c. So we're replacing both of the n's with 1. And we know that T1, or term 1, is 1. So the first term is 1. So we have 1 equals a half plus b plus c. And then we do letters to the left, numbers to the right. And we simplify to get b plus c is equal to a half. So we have an equation in terms of b and c. We do the same thing then with 2, T2. So we're replacing both of those n's for 2 with brackets and letting T2 be equal to 3 because we know that term 2 is 3. So we get 3 equals 2 plus 2b plus c. And then letters to the left, numbers to the right. And simplifying, we get 2b plus c is equal to 1. So now we have a second equation in terms of b and c. So now we can use both equations to solve for b and c. So we're going to solve simultaneously for b and c. So we have b plus c equals a half and 2b plus c equals 1. So we're going to change the signs of one of the lines. It doesn't matter which one. I'm going to change the signs of the bottom equation. So the top equation stays as b plus c equals a half. And then we get minus 2b minus c is equal to minus 1. So now the c's will cancel. And we get minus b equals minus a half. So solving for positive b, we get b is equal to a half. So now we know what b is. Now we need to find c. So we're going to sub b into one of the equations. It doesn't matter which one. I'm going to go for the top equation. So I have b plus c is equal to a half. So substituting in place of b, I have a half plus c is equal to a half. Solving for c, I get c is equal to 0. So again, our pattern is 1, 3, 6, 10, ... Our Tn formula for a quadratic pattern is a half n squared plus bn plus c. We know that b is equal to a half, and we know that c is equal to 0. So we get Tn equals a half n squared plus a half times n plus 0. So a half in place of b and 0 in place of c. So simplifying, we get Tn equals a half n squared plus a half n. And then substituting 30 in place of the n's, we get a half times 30 squared plus a half times 30. and that gives us 465 tiles. So the number of tiles needed for the 30th pattern is 465.